A bullet is fired straight up and takes 12.2 seconds to reach its peak. Determine how high the bullet goes and its initial velocity, magnitude, and direction. Ignore air drag. Okay, so what's happening here is I've got this bullet, all right, and I'm firing it straight up, and it's going to go up, and then of course it's going to come back down. But we're only interested in it going up, at least for the first part of this problem. So we want to know how high that is. All right, so we're interested in this. That's the max height. That's what we're interested in. Okay, so we're also interested in, of course, the initial velocity. So those are the two things we're interested in, but we got to start by having an understanding. So that's why I drew a picture to make sure I had straight what was happening. And then we want to write down what we know. So what do we know? Well, we're told that delta t equals 12.2 seconds. Okay. Let's see. It's fired straight up. Oh, so this is going to be free fall, right? Once it leaves the bullet, there's nothing else acting on its own. It's in free fall, so I know that the y acceleration is going to be, we'll call up positive, so this will be negative 9.8 meters per square second. Right? So up is positive. And the other thing that I know is that when I get to the peak, because what we're interested in is the max height. So that's going from here to here. And so that tells me that the velocity at the peak, or you could say the v final, okay, but recognize it's at the peak. So in fact, I'm going to make that clear. I'm going to write v peak equals 0. Okay, so now I want to find the max height. I want to find vi. So if you go and look at the formulas, every single one of them has the initial velocity in it. So we have to find the initial velocity first. So let's just start going through the formulas. I'll write down the first one, v final y equals v initial y plus ay delta t. So v final y, that's this. This is 0. We don't know the initial. We know ay, we know delta t. Great, we know everything in here except for the initial velocity, which is what we're looking for. So this is 0, the initial y, plus this is negative 9.8, and the delta t is 12.2. So multiply these together, and I'm going to get 0 equals v initial y minus 9.8 times 12.2. That's 119.56, excuse me, 56. Okay. And so move that to the other side, and I get, of course, 119.56 meters per second is the initial y velocity. And that's going to be the answer for right here. This 119.56 is going to go up here. Notice that it's positive. I said up is positive, so the initial y velocity is 119.56 meters per second, and its direction is up. And of course, we knew it was going up to begin with. I mean, we were told that, right? So no surprise. But if I was doing another problem, I might not know which direction it was going initially. And if this came out negative, well, then that would tell me it was going the negative direction initially. Just depends on the problem. Now that I know that, I can find the, what am I looking for? The max height, okay? So just to use a different formula, we'll use delta ry equals 1/2. We can use this many options here at this point, but I'm going to use this one. You could try a different one, and you should see that it gets me the exact same answer. In fact, I might do that as well, just to show that. Delta ry, let's see, this is 1/2. V initial y, I just found that, 119.56. VFY is 0. Delta t is 12.2. And so if I do this, I get 729.316. And that'll be meters. Okay. And as I said, we have options on the formulas we can use here. We don't have to use this one. And so just to show what I'm talking about, I'll use a different one. we've used this one a bunch, so I'll use it again here. So V initial y is 119.56. T is 12.2. Plus this is 1/2 times negative 9.8 times 12.2 squared. Okay. So I'm just going to type this all into my calculator at once. And when I do that, what do you know? I get the exact same answer we just had, 729.316 meters, because it doesn't matter. And just to take it all the way, we'll just do the last formula that we could have chosen, which would be this one, V initial y squared plus 2ay delta ry. V of y squared, that's 0. V initial y squared, that's the 119.56 squared plus 2 times negative 9.8 times delta ry. Okay. And so that's going to become, this times this is negative 19.6. I'm going to bring it to the other side. So it becomes 19.6 delta ry. And 119.56 squared. That's a big number. That's 14,294.5936. And I'm going to divide that number by 19.6. And I get 729.316 meters. And I just did this all just to show you the formulas are all in agreement with each other. It's not like you can only use this formula in certain situations, but it won't apply to this other situation. They all apply. It's just a matter of which one helps you solve the problem. The one that helps you solve the problem is the one that has the unknown that you're looking for, and you know everything else. So that's the one that is the one you want to use. In this case, we could have used any one of these three to get delta ry, and as long as we're doing it correctly, it doesn't matter which one we choose because we get the exact same answer. So that's all I wanted to show by doing that the three different ways, using the three different equations.